Ken Forster, Executive Director at Momenta. Welcome to our Digital Thread podcast, produced by, for, and about digital industry leaders. In this series of conversations, we capture insights from the best and brightest minds in digital industry. They're executives, entrepreneurs, advisors, and other thought leaders. What they have in common is, like our team at Momenta, they are deep industry operators. We hope you find these podcasts informative, and as always, we welcome your comments and suggestions. Good day and welcome to episode 177 of my Momenta Digital Thread podcast series. Today, I'm pleased to host Evgeni Gousev, chairman of the tinyML Foundation, a nonprofit organization with the mission to accelerate the growth of a prosperous and integrated global community of hardware, software, and system scientists, engineers, designers, product, and business application people developing leading-edge, energy-efficient machine learning computing. Evgeni is a senior director of engineering in Qualcomm Research, leading the hardware R&D organization in the Silicon Valley Center. He's responsible for developing their ultra-low power embedded computing platform, including their always-on machine vision AI technology. He has been with Qualcomm Technology since 2005 after joining from IBM's T.J. Watson Research Center, where he drove projects in the field of advanced silicon technologies. From 1993 to 98, Evgeni held academic professor appointments with Rutgers University and Hiroshima University. He holds a Master of Science degree in Applied Physics and a Ph.D. in Solid-State Physics, has co-edited 24 books, published 163 papers, and is an inventor on more than 60 issued and filed patents. Evgeni, welcome to our Digital Thread podcast.
Thank you, Ken, for the introduction. It is a great pleasure to be here. And by the way, I like the episode number 177 because 17 and 7 are two of my favorite numbers. Thank you for giving this number to me.
Wow. Yeah, I'm a numerology guy myself. And of course, we just passed 2/22/22 a couple week or so ago. So it made for an interesting day. But I really appreciate you taking the time to join us. And that mouthful of a bio says so much about who you are and really the experience base you have. So really happy to have you join us today, and especially talking about a topic that's near and dear to our heart in the form of tinyML. So let's start with you. What would you consider to be your digital thread? In other words, the one or more thematic threads that define your digital industry journey.
Yeah, I've done quite a bit of different projects and different industries and different technologies throughout my professional life, and starting like from deep silicon technologies, moving into other areas like MEMS, displays, and UI technologies, and so on. But these days, I'm very, very fortunate and I'm super passionate about tinyML technologies. tinyML technologies include a set of hardware, software, algorithmic techniques that enable and allow to do machine learning and artificial intelligence at extremely low power, like very, very low power. And that enables, in turn, battery operated devices. And the cool thing about tinyML, it's super interesting on the technology side, but I am very passionate about the impact these technologies can have in our lives, both as consumers and as citizens. I think they are super powerful, and we are at the beginning of a big tinyML revolution and how it's going to change our life.
I couldn't agree more. And in fact, PitchBook published an interesting perspective on tinyML last year and had very good things to say, very much aligned with what you have as well, looking at it as a major theme for potential investors in this space as well. You're certainly uniquely qualified to talk about this, given that you've been in the leading edge of R&D for almost 25 years now. So as you mentioned, silicon design, MEMS, human-machine interface, interesting enough, and now ultra-low power edge, including machine vision. Let me ask, if you had to boil all of this down into three key insights about those technologies in your time in there, what would those be?
Yeah, I think 25 years is quite a bit of time, and actually it flies. It feels like yesterday. And over these 25 years, I've been very fortunate to work with very bright people in the world and really working on extremely challenging technologies. And when you work with very talented people on like kind of mission impossible type of technologies, you do collect some scars. And over these years, I've accumulated these scars. I've been going through ups and downs, as many of us are. And I would boil this down, kind of my lessons, to three key ones. First one is the first one I learned when I was at IBM about 20 years ago, and kind of became very clear to me then. Back then, we were working on advanced silicon technologies. And when I joined IBM, we were working on 180 nanometer technologies. And when I was leaving IBM, we were working on 45 nanometer technologies. And at that time, nobody believed that there will be technologies beyond 45 because optical lithography was like 0.18. Like, what do you do if like you're hitting the physical limits of things? And what I learned from this lesson was, and now we are in 4 nanometer in production. That's kind of what we do in Qualcomm. So like we are a factor of 10 less than it was impossible back 15 years ago. So the first lesson I learned from my IBM days was that technology progress is pretty much unstoppable. So if there is a driving force and if there is a bunch of great talent in the world, and we do have a lot of talent in the world, kind of combined all companies, all countries, all disciplines. So the technology progress is never going to stop. Like even if you feel like you're hitting a dead end or a wall, there are always solutions there. And that's kind of, I keep thinking about this quite often. Like when we run into some kind of issue or roadblock, I kind of remember my IBM days. Like there is always a solution out there. It's not obvious initially, but then kind of it becomes obvious when you solve a problem. Again, the point number one, no matter how the problem is, there is always a technical solution for this problem or a way around. So that was my lesson number one. Number two was I've been very fortunate since my kind of early days working for the industry to work on, as I said earlier, very tough problems. So I think as a result of this, we had to develop a very unique disruptive technologies to find a solution there. And what I learned from those days, and again, doing disruptive technologies is a lot of fun. I mean, it's not easy, right? But it's a lot of fun kind of going through all the hurdles and finding a solution at the end. But what I learned from this is, and I think that's a great also lesson for startups who are entering this field, any field, that really to be successful with disruptive technologies, you really need to shoot for 10x improvement, at least 10x improvement in any of the parameters. Like you need to be either 10x lower power or 10x better performance, or you need to develop something 10x better in terms of user experience. So really kind of, for me, this 10x factor is quite important. Like when I start any new project, either in Qualcomm or kind of work with people externally, this 10x is kind of my guiding principle because it takes time to develop technologies. And by the time you're kind of done, the state of the art also advances. So I think if you get like 2x, 3x at the end, I think then you're lucky. But I think that your starting point should be at least 10x. So that's my lesson number two. And lesson number three, or the insight number three, is really to be successful these days with the technologies we are developing, especially in the AI space and tinyML space. You really need to look at your systems and solutions holistically because that gives you the most competitive advantage, that gives you most edge. You really need to understand most advanced hardware technologies and like specifically in tinyML hardware accelerators and the silicon tools. You really need to understand and design most efficient algorithms to be able to run on this hardware. And on top of this, if you don't have a good software layer that can deliver this advantage to the use case, to the customer, then that's kind of pointless. So you really need to look at the systems and the products you're developing holistically from kind of all this perspective. And here, I am very fortunate that I also keep thinking about this more and more often recently, and I kind of also promote it to younger generations. I'm very thankful to my physics background. I have a degree in physics, solid state physics, and microelectronics. And the physics background gives me this kind of holistic way of looking at things because we physicists are trained to look at the systems kind of by connecting laws, by connecting dots and laws of physics. So those are the three ones that probably stand out. There are many other ones, and I can again recap them. The first one is really, there are always solutions to hard problems. Just don't give it up and work with smart people collectively to find those solutions. Number two is the 10x factor. For new disruptive technologies, at least 10x should be your starting point. And number three, really look at the solutions from the holistic perspective, from the overall perspective, including specifically in the tinyML space, it's the hardware, the algorithms, the software, use cases, everything. That's my long answer to this very interesting question. Thank you for asking, Ken.
Great. So be tenacious, aim high, at least 10x, and think, or I should say, engineer holistically. So 3 great learnings there. And I'm sure Gordon Moore would agree with you on the 10x improvements there in terms of Moore's law. So let's dig into tinyML. You started to talk about it a few minutes ago, but what is it? Tell us a bit about the origin story and really what attracted you to this space.
Yeah, I think my tinyML journey started around 2014. And again, it started from this kind of 10x thing. Actually, at that time, it was 100x thing. In Qualcomm back then, I think we were really charged to do new disruptive things. And one of the tough problems we were trying to tackle was computer vision, machine vision. So back then, the kind of the state of the art was like, if you want to get a recognition of a person or a car, or whatever, and do classification there, what do? You take a camera. Typically, these high-resolution cameras, they consume tons of power, like any security wired cameras. And this is actually true also today. So then you take a picture, let's say you take a picture of a person or a picture of a car, and then that takes quite a bit of energy or power, typically hundreds of milliwatts. So then on top of this, you need to transmit this data to the next level where you do processing, like the CPU or GPU or DSP type of core. And then you do processing there. And the algorithms back then were not really very efficient because they were designed like more for big CPUs and for the cloud. So that consumed also on the order like a few hundred milliwatts. And then the transmission part. So when you add it up, it was like you get like half a watt type of power. And we challenge ourselves, like, why is it so high? Because we wanted this computer vision to be always on. And our definition at Qualcomm of always on technologies was less than 1 milliwatt. So again, we're talking about more than a factor of 100. So like 1 milliwatt versus like 500 milliwatts. Because I think 1 milliwatt was a magic number from the cell phone market, because for cell phone technologies to qualify for always on, like any kind of sensors, like accelerometer, gyro type of sensor, touch sensor on the screen, you really need to be less than 1 milliwatt. Otherwise, you're going to drain your battery in no time. So we kind of had this challenge for ourselves. Why always on vision is impossible? And when we started this project, it was like, wow, no, there is no way we can do it. Like, hey, it's again kind of back to the point I made earlier, point number 1. Like, you're running into big roadblock and you said, okay, that's it. Let's have a U-turn and go home. But again, my team and I, we had, especially my team, my folks, very smart people there. We've been thinking about this problem for about like 6 months. And after 6 months, we started seeing light in the end of the tunnel. And the key for us was, again, this kind of holistic approach. We look at the whole thing holistically, like, hey, why the sensors consuming so much power? Why the algorithms are so power hungry? Either way we can design a better processor, better computer to run these algorithms. At the end, we came up with this unique solution. It was a year after, kind of magic 1 milliwatt type of number. And that opened up the whole new area for us to innovate and to commercialize this type of technology. So basically, for the first time in the industry, we enabled always on vision, and we kind of started this productizing this from 2011. So, and that's kind of took us very broadly to this tinyML space, because effectively back then what we developed a very efficient hardware to be able to run very efficient algorithms to be able to do machine learning. And that's kind of the definition of tinyML. And then the more we thought about this, we thought, wow, this is going to be quite disruptive. This is going to be big because, again, for the first time, you can enable so many interesting use cases and you can run those on battery operated devices. And this is hugely disruptive. That's basically how the whole tinyML motion started, kind of from us, from IBM, and then talking to our partners. And then we can talk where we are now.
So you've co-founded the tinyML Foundation in 2018. Tell us a bit about the goals of this foundation.
Yeah, absolutely. So I think that kind of goes to my DNA of being a collaborative type of person. I'm a strong believer that these days, to develop technologies and develop them fast, you really need to partner with the right people. You really need to kind of develop the whole ecosystem there. So the way specifically kind of how tinyML Foundation started, around 2018, actually a little bit before this, we start socializing these ideas with our customers. One of them was Google. And specifically, Pete Warden from Google, he was one of the key people there. And one day I just visited Pete here in his Mountain View office, and we talked like, hey, what are we going to do about this? Because they started some activities in tinyML at Google. We've been working on Always on Vision for a couple of years, and we thought, wow, this thing is going to be big. Let's create something and kind of drive this ecosystem forward. And we thought, well, let's start with baby steps. Maybe we'll have a workshop. We'll invite people there. And then we talked to a couple of other people. We talked to Boris Moorman from Stanford. We talked to folks from ARM and other companies. And we had like small committee, about 5 people there. And we had a very modest goal back in the 19. We thought like, hey, if you're going to have this workshop and we're going to have 30 people there, that will be success. So we started promoting this thing, and in 3 months, we had like over 200 people knocking our door. And for us, it was a great indication and great testimony that the community and the ecosystem is ready for this type of things. And then we really started kind of driving this pretty hard as a global tinyML ecosystem. And it's we kind of organized it formally as a nonprofit organization, again, starting from couple hundred people. I mean, yeah, like what we had, like 160 people at our first summit. And now we're talking about thousands. I think we're going to be close to 10,000. And tinyML community is truly a global community. It includes groups there are 44 groups in 34 countries. It's basically all over the world, a lot of energy, a lot of talent there. And what kind of makes this unique is developing tinyML communities in terms of equipment, in terms of tools. You don't really need to have much investment. So it's really a way to democratize AI, big way. So really give technology to people who want to use this technology to solve problems around them in a cost-effective and kind of very fast time to market type of fashion. So that's kind of what keeps us going these days, is really how do we drive these technologies into the ecosystem, into the end users, and teach people and enable all these new interesting applications around us that will be effectively game-changing both in the commercial space, but also in the social space, in the info-good space. So again, today, it's been, 3 years. It's been an amazing evolution of this community. We're going to have our summit, by the way, tinyML Summit, our annual flagship event in 3 weeks here in the Bay Area, and it's going to be in person. So I think super excited about that one too. And just an illustration, as of today, we have like 44 sponsors, company sponsors sign up for this. And we have more than 30 strategic partners, really kind of great ecosystem and a lot of support from the industry and from the academia there.
Well, I couldn't agree with you more about certainly the impact and potential of tinyML. In full transparency, we're, of course, big fans at Momenta, having invested in 3 rounds for Edge Impulse, Zach Shelby's company, which is the leading tinyML DevOps platform, if you ask Zach. But I know Zach and Edge Impulse are cornerstones of the foundation as well. You mentioned the sponsors and strategic partners. What are some of the other more notable companies that are part of the foundation at this point?
Yeah, Edge Impulse, they've been active since pretty much day one. In fact, I had lunch with Zach Shelby before we started the foundation when he was still at ARM. And Zach was thinking, same thing, like, hey, tinyML is going to be big. I need to do something about it. So he went and started Edge Impulse. And Pete and we went and started tinyML Foundation to support this. And we really collaborate really well. And I think we also appreciate organizations like Momenta also recognizing this earlier in the game and helping companies like Edge Impulse and others to kind of accelerate their business in this space. But to answer a question on the more notable or most notable companies, my kind of short answer is there are none and there are all, because the beauty of tinyML ecosystem is all inclusive and it's so diverse, so that every single player there is important. Every single player is bringing its own unique value, its own unique skills, its own unique capabilities. And it's a global organization. So we have companies doing hardware, software, AutoML tool, neural architecture tool, many companies doing hardware, people working on analog compute, people working on compute and memory, people working on updates over air, firmware updates over air, people doing type of technologies, end user companies like Sony are members there, companies, big enterprise companies like SAP They're strategic partners. They are Google, Qualcomm, NXP, ST Microelectronics. I mean, Renaissance, all major Maxim integrated log devices, all major silicon companies are there. But again, to me, it's not really kind of the big names type of thing. It's really the diversity that is the key for tinyML global community and the ecosystem to be successful. Because again, every single member of this organization, global organization, contributes with their skills, with their expertise, with identifying pain points for the industry, and also kind of helping to solve these points with their skills, with their knowledge, with their technology. So, and we are very proud that I think we built it from the very beginning. That's kind of our DNA of the organization, the diversity and kind of inclusion and being open and transparent and really kind of being industry driven, focusing on high quality stuff. So again, back to my kind of answer, it's known and all, because I wouldn't highlight like one organization. I mean, obviously Edge Impulse is known to Momenta because you sponsor them, you fund them, but I would say every single player, small company, big company, they're important and they do bring value. And this list of companies is growing like big time. I think every week we have more and more companies joining because they see the value, they see the opportunity, and they like the culture and the ecosystem we are promoting.
So I would have expected nothing less than you giving me the egalitarian answer, given you're an ecosystem builder. And I appreciate the fact you are. But I'm going to put you on the limb once more time in that I'm curious about what are some of your favorite use cases or applications of tinyML that you've seen out there?
Yeah, I mean, if you go to the fundamentals of tinyML, what tinyML is? tinyML is, again, it's a set of technologies that connects the digital world to the physical world. So I think ultimately that's the way to do device analytics and data analytics right at the boundary of the physical and the digital world. And that's why it's super powerful and it has tons of applications, tons of opportunities there, because effectively, if you think about the physical world, there are all kinds of sensing modalities there, right? We have a lot of information in the physical world coming from audio type of signals. I think human perception, about 11% of human perception, we humans, we perceive the world through our ears. The other big modality is vision. About 80% of human perception comes through our eyes. So a lot of technologies, a lot of information is coming through vision type of sensors. And then we have other type of sensors. So we have temperature sensors, we have vibration type of sensors, we have infrared sensors, any kind of sensors. So the beauty of tinyML, again, it collects all this information from the physical world and kind of analyzes this locally at the very edge, right at the boundary of the physical world and the digital world. And talking about use cases and kind of my favorite use cases, these use cases can be grouped in this kind of different categories on the sensor modality. And I think some market analysts kind of look at this or break this down this way too. There are vision applications, vision-based applications. There are audio type of applications, and there are other sensors type of applications like, let's say, accelerometers, gyros, temperature type of sensors. So there are tons of applications in all these spaces. The ones that are getting pretty good traction now, they are in industrial IoT specifically. Many companies doing this, like predictive maintenance and anomaly detection. Like, for example, some cases, like you can put a tinyML device to a motor in a factory or a pump or an engine or an aircraft or your car engine, and you can start, or a pipeline, and you can train the system to detect normal type of behavior of this machine or engine or whatever, a motor, from abnormal type of behavior. And this is very powerful because this use case allows companies to save big money on kind of maintenance and repairs and all these kind of things. And it provides real-time analytics to be able to do a lot of things there. So there are many applications in the audio, like keyword detection, and again, certain cases like where you can train your models to distinguish certain sounds, like, for example, breaking glass in your house. If somebody breaks in, then you can detect this. You can train your tinyML audio system to be able to do it. Or gunshots, or you can distinguish like a big truck from a passenger car type of sound. So I think many applications in this space. And then obviously in the vision space, there are like tons of applications in all industries, like retail. You can monitor traffic in physical stores. You can monitor items in the store. You can monitor empty shelves. You can monitor a customer attention to specific items like dwell time, how much time people can spend in front of a particular item on the shelf. Do they like it or they don't like it? So you can do kind of a lot of real-time analytics, which is very valuable for these particular businesses, or in logistics and transportation, asset trackings. I mean, a lot of things where you really need to get real-time data, and you would like to do it at extremely low power, to be able to do it on a battery, like a coin cell battery, but also to be able to do it at extremely low cost. So basically, when you add this type of solution, like to a packaging box to track it, you're not adding tons of overall cost for the system, but yet you're getting real-time analytics. So those are some examples and use cases kind of industrial IoT. There are many kind of world around us, like in the smart home, or what people starting to call metaverse now, although to me, this is kind of quite controversial topic. Like, why do we need this metaverse if you have this beautiful universe to live? But that's probably a separate podcast on this. But what is metaverse? You really need to have a bunch of sensors around us that will help and guide us and augment sort of like human senses. And that's what tinyML offers to do. Like classical example of this would be AR, VR headsets, because these devices, they require quite a bit of compute, but they're really constrained in terms of form factor, constrained in terms of thermal management, they're constrained in terms of how big battery you can put there, in terms of compute. And that's where tinyML comes to play and kind of offer a unique solution, kind of talking about, again, 10x type of advantage. I think that's in AR, VR, tinyML can definitely offer this 10x improvement and kind of be disruptive for many use cases and features there. This area, the whole kind of metaverse area, how do you enable all the smart devices and do it in a very energy efficient way? And but then I think these days I'm also super passionate about using tinyML for good, giving this technology back to the society, giving this technology back to people, because there are so many people this technology can be used to improve our life around us in many ways. Like, for example, wildfires in California, for example, kind of due to the climate change, every year we have more and more wildfires in the US and kind of worldwide. So this type of devices, if you deploy them in forest, you can get real-time data, real-time analytics on what happens there, if there is any smoke or any fire or any kind of increased temperature, any kind of increased infrared activities. So you really get this real-time data and kind of use it for good, or in education, in STEM, or like we have one company in tinyML in Kenya, in Africa. And I really love this example because it's kind of a good illustration how tinyML technology can be used to solve local problems. So this company is called iBees, like bees, these creatures that produce honey. Because apparently what I learned that honey business is a big one in Kenya. There are like 90,000 farms there, and they produce quite a bit of honey, obviously. But the pain point for them is they're losing 30% of their honey because there are some diseases in the bee hive, in the bee family, or people stealing them, or there is some kind of disruption to them. So basically, they're losing 30% of their revenues of their production because they don't really have this kind of feedback. So what this company developed, they put a tinyML device with temperature and audio type of sensors inside of the beehive, and then they can monitor the health and the environment and the condition of this beehive real time, kind of sort of like similar to the motor in the industrial IoT environment. You kind of are looking at abnormalities and you're monitoring abnormalities, but you can do it in this kind of beehive environment. And that helps them to save money big time. And it brings technology to this honey farms. So, and again, this is a great illustration because it shows a couple of things. It shows how easy to use tinyML technologies, how low the barrier is for people to use it in the developing world. The cost of these technologies is quite low. And then we have a community of people all over the world who are really passionate about applying these technologies to solve problems around them. And that's what makes tinyML super powerful because, again, the barriers to use is quite low. The technology is available, both hardware and software. Again, companies like Edge Impulse, they offer their tools for free for people to develop these technologies. There are silicon technologies available. There are companies in the tinyML ecosystem who design boards and development kits and this type of thing. So really, if you have a problem and if you want to solve it, tinyML would be the way to go to do it at extremely low power. And like on the extreme case, we have an example, which is also one of my favorite. Last year, we had tinyML Vision Challenge. We basically had a contest, and we asked our global community, hey, come up with new use cases for tinyML Vision, and had like 500 submissions, not some 500 participants there, of which we selected 5 winners. And one of the honorary winner there was a team of 5 to 9 years old kids from Toronto, from Canada. So they developed a tinyML application for smart bird feeder. So basically the application was to distinguish a bird from a squirrel, because apparently squirrels eat quite a bit of food from these bird feeders. So again, it shows how easy it is to use a tinyML solution. So like even in this case, not even like high school kids, like elementary school kids over the summer were able to develop their own solutions and train a model and show you can distinguish a squirrel from a bird. So that's what keeps me very passionate about tinyML and very optimistic that technology is there. We have a huge global community and there are just so many use cases around. And I think we are really looking forward like how this technology can be used both for good, to change kind of to make life better around, and also obviously for commercial use. And kind of to summarize this long story on the use cases, that's why the mission statement or the vision statement of the tinyML Foundation is we see a new world with trillions of intelligent devices enabled by tinyML that act, worked, and together autonomously to make a better sustainable world and healthier world for all of us. So that's a super powerful vision statement. And it's not a science fiction. That's kind of what tinyML can do. And that's what we're seeing happening as we speak.
Excellent. You're very passionate about it, which is great. So to learn more about tinyML and the tinyML Summit coming up in 3 weeks, go to www.tinyml.org. So, Evgeni, thank you for sharing this time and insights with us today.
Well, it was a great pleasure and a privilege, Ken, for me to be here and to share the latest and greatest and the progress on tinyML and what is happening around us on the technology side and on the application side. And if you're interested in joining us, as Ken said, go to the tinyml.org and you see tons of information there, or you can connect to me on LinkedIn and we'll be happy to work on helping you with any kind of questions or discussing collaborative opportunities and so on. And again, thank you for having us here today, and it's been a pleasure.
As well, thank you so much. So this has been Dr. Evgeni Gousev, Chairman of the tinyML Foundation, dedicated to developing leading-edge, energy-efficient machine learning computing, and I might add, at 10x. So thank you for listening, and please join us next week for the next episode of our Digital Thread podcast series. Thank you, and have a great day. You've been listening to the Momenta Digital Thread podcast series. We hope you've enjoyed the discussion, and as always, we welcome your comments and suggestions. Please check our website at momenta.one for archived versions of podcasts, as well as resources to help with your digital industry journey. Thank you for listening.